Absolutely not.
Okay. And actually, I think before, okay, we did these examples. BenQ, of course, erased over Thanksgiving, but reminder, we were talking about extreme value theorem, EVT. Okay, we'd already done some examples and looked at some cases, but if f is continuous, remember that was a big deal, it has to be continuous on this closed interval, then there is guaranteed that there is a max value and a min value on that interval, somewhere either within the interval or at the endpoints. Okay, and so that's what we were talking about, is that these max and mins, these extreme values on a set interval, there has to be a min and a max as long as the function is continuous. And we had looked at these examples here, and pretty much they weren't continuous. There was some issue with all of them, okay? Or it wasn't a closed interval. Now, I moved that, and I know I had stuff circled, but that's all right. Not half bad. I'm just going to leave it there. Okay, so the extreme value theorem, the comment I was going to point out here before I move on, gives us a knowledge of when extrema occur, that extrema will be there, okay? The question is going to be how we find them algebraically, and we'll get to that before the end of the lesson, but how we find them algebraically when given an equation and you don't have a graph, okay? So, in other words, basically when it's a non-calculator problem, how do you find those extrema, okay? How can we identify all the values of x where extreme values occur? So we are going to be talking about that. Example 5. Example 5 has ABC. And asks us for each of these functions shown below to justify or explain why the extreme value theorem, EVT, can be applied or why it does not apply on the given interval. Okay? F of x, on A, f of x equals 2x minus 3 over x minus 2. And the interval is -4 to 4. Thoughts on why EVT can be applied or why it does not apply?
We have to
Well, my hint is I would focus on why this one does not apply.
It doesn't apply because it's not continuous.
And where is it not continuous at?
At, wait, x equals 2.
x equals 2.
Yeah.
Right?
So the denominator.
Right? Okay, are you there now?
Yeah.
And when you have a denominator, if there's a place that will make that denominator equal to 0, that means there's an issue. There's either a vertical asymptote or there's a hole. Okay? There's not another x minus 2 there, and regardless, it's not continuous. Okay? If you have a denominator that can be set equal to 0, it's not continuous. So right there, it's not continuous at 2, and is 2 in the given interval? It is. If 2 is outside the interval, it wouldn't be an issue. But since 2 is in the interval, it is an issue. So yeah, this is I feel like we've had lots of these when this does not apply. We will get to some when they apply, but EVT does not apply on this interval because f of x is not continuous at 2, which is contained on the interval. So, however you want to write that out, I'm going to say EVT does not apply on -4 less than or equal to x less than or equal to 4, since f of x is not continuous at x equals 2. A lot of this comes down to right here is not necessarily knowing what this graph looks like, but knowing pieces about what this graph is telling you. Okay, maybe what is the general shape of the graph, or what are the catches? Like here, the denominator is the catch. Okay. You guys ready to talk about B? G of x equals e to the x minus 2 plus 1, and the interval is -5 to 5. Thoughts on whether or not EVT does apply or EVT does not apply?
Yes.
Yes? Why?
Because there's nothing that says it doesn't.
Okay, nothing that says it doesn't. In other words, there's not a denominator like last time, right? And here's the key. Is this a continuous graph? What's e to the x look like? What?
Isn't it like a who knows?
I think of an e to the x graph, an exponential curve. Okay, whether it's e to the x, 2 to the x, 3 to the x, some type of exponential curve. Your basic graph runs here along the x-axis, right? And then after it crosses through 1, it goes exponentially up, yes? Now, what would the x minus 2 and the plus 1 do to this graph?
Right.
It'd move it 2 to the right and 1 up, yes? Those Algebra 2 days coming back to you, okay? So, is it going to be continuous on the interval -5 to 5? Yeah. Okay, so we can say, yes, that EVT does apply on this interval because g of x is continuous. I have it written as g of x is continuous for all reals. Okay? G of x is continuous. Ooh. Oh my goodness.
Continually.
Don't ask me to spell continuous today. It's not going well. Okay. G of x is continuous for all reals. Thus, EVT applies on -5 less than or equal to x less than or equal to 5. Yeesh, that was rough. Only because I can't spell the word continuous. Maybe this is why I abbreviate CONT a lot. Okay. Okay, same question on C. H of x equals x times the square root of x plus 2. And the question is on the interval from -6 to 6. Any thoughts here? My hint will be, do we want to hit? Yeah. What do we know about square roots?
Okay, that's what I was
To the
thinking.
one
Just
to the half.
how would that?
Wait, what'd you say?
It's raised.
Oh, 1/2 power. Not thinking about 1/2 power, just thinking about partially a graph, although we have that times x, so I don't exactly know what the graph looks like, but if you just think about the square root of x graph, that will get me there. What's the square root of x graph look like? Okay. Well, if you don't remember that, then just what do you in general know about square roots?
Oh, so it's gonna be split up.
Is it like the
What do we know about what's under a square root? So let's talk about the square root of 4 versus the square root of negative 4.
the ones?
The one's imaginary, yes? Are we talking imaginaries in this scenario? No. Okay. Unless you are in the complex number world, which in calculus we generally work in real numbers. Ooh.
Yeah,
It's not a good noise.
Okay. We generally work in real numbers. In terms of real numbers, what do you know about a square root? It has to be what? Positive. Whatever's under the square root has to be positive. What's under the square root here? X plus 2. So the value x plus 2 has to be positive. When I say positive, I mean greater than or equal to 0. So x has to be greater than or equal to negative 2 when you solve that. In other words, any value I put in below negative 2 is going to make my square root negative and not a real number. So EVT does not apply because negative 6 to 6. It's fine from negative 2 to 6. If this interval was different again. From negative 2 to 6, we're good. But it's that negative 6 to negative 2.01 type area that doesn't work. Okay, so you guys remember denominators. Square roots is the other thing. Whatever's under a square root has to be positive. Okay, so h of x is only continuous when x is greater than or equal to 2. EVT does not apply then on the interval negative 6 to 6. Let's see. Since h of x is only continuous on x greater than or equal to negative 2, EVT does not apply on the interval negative 6 to 6. Okay, so that's kind of more about the equations, how to know just by looking at the equation, okay, because we don't always have a graph to look at. So that's one. You have to be able to know, is it continuous, so I can even apply EVT. Now, at the bottom of this page, it talks about the definition of a critical number or critical value. And I've thrown this out there a little bit on occasion, just because I kind of forget we don't learn that terminology, critical number, till now. But a critical number or critical value of a function is an x value in the domain of f such that either f prime of c equals 0 or f prime of c does not exist. Okay, so critical number or critical value happen at one of two times. When the derivative at that point equals 0, or the derivative at that point does not exist. Okay? The most often thing we talk about is when does the derivative equal 0. That's going to be the big one. Derivative does not exist. Okay, then we throw in, okay, if there's a denominator or something. But most often we're talking about when the derivative equals 0. So if x equals c is a critical value, then plugging that in, c comma f of c is called a critical point. Okay? So, we're going to talk about that a lot moving forward. That's what we're going to look at on the next page, is finding critical numbers. How do we do this without the calculator, basically? Or how do we find these places without the calculator? Let's see. Relative and local extrema can only occur at a critical value on an open interval. Okay, so your relative or local are only going to happen at a critical value. Your absolute or global, gosh, I can't talk. Absolute extrema must occur at either a critical number or they can occur at an endpoint. Okay, if your highest or lowest spot is an endpoint on an interval. And that brings us to something called the candidates test. And that idea is once you have all your critical values, so any place the derivative equals 0, the derivative does not exist, or endpoints, then we're going to do something called the candidates test. And that's where we actually will just go through and find the y values and use those. Okay? So something called the candidates test. And that's what we're going to practice on this next page. Now, on this next page, let me just get this out of the way right up front. It does say calculator. However, that's not, we're going to use the calculator to graph. Okay, we're not looking at graphs here. That is, we're going to use the calculator to find the y values. Okay, so just, we're only using it to find y values. Because the whole point is learning how to find critical values when you can't look at the graph. Okay, that's our point today. So, on A, we have f of x, and we're talking about on the interval from -1 to 2. First of all, what should we probably double check before we do anything?
Continuous.
Is it continuous?
Yes.
It's what we would call a polynomial.
Yeah.
And so it's going to be continuous, okay? We could look at it, oh, yep, that's a polynomial. It's continuous everywhere, so it's continuous on -1 to 2. Okay, so I'm looking for my critical values, okay? Because our goal is to find our absolute extrema. So our absolute max or absolute min. In order to do that, we need to find all of our critical values on this interval. So in order to find critical values, any place the derivative equals 0 or the derivative does not exist. Which means we need to start off finding the derivative. Good news, it's an easy derivative, if you haven't forgotten too much. I don't think you guys forget this, do you?
No.
I just realized.
Okay, so we know how to find the derivative, we just don't know what 3 times 8 is. Fair enough. Okay, what do we got here?
24x minus 6.
Okay, 24x squared minus 6x minus 9?
Yep.
And are we going to have any place this derivative does not exist?
Nope.
No. We need to set this equal to 0. Now, what's the first thing you notice?
Factor out 3.
GCF of 3? So if I'm going to factor out 3 as I go here. Now I'm left with (8x squared minus 2x minus 3).
Yeah. Product of AC.
Product of AC, slip and slide, guess and check.
816.
Oh,
-6 and
there's no way.
+4.
I know at least Tate's going on without me. So I'm sorry, I got sidetracked. Multiplying to be -24, adding to be -2. And so,
-6.
okay, -6x plus 4x You still have the minus 3 at the end. You still have the 8x squared at the beginning. I don't know how much review we need on this, but okay, perfect. GCF of the first two is 2x. Then I have 4x minus 3. GCF of the last two, the way I have it set up is 1. So 4x minus 3. So my parentheses, I have a 3 out front. I have a 2x plus 1. And I have a 4x minus 3. Yes? Maybe? Okay. Now, what do we have in the way of critical values? We're going to what? Officially set 2x plus 1 equal to 0. 4x minus 3 equals 0. That 3 out front, it's a constant. It doesn't matter. So what do we find here? Okay, x equals negative 1/2. X equals 3/4. These are what we're going to call our critical values. No, these are not necessarily extrema yet. We're not done there. These are critical numbers, critical values. I'm going to use critical numbers, I guess. Now, if you're in a scenario where you can graph it, yeah, you can easily just figure out, okay, where, what's going on at those points. We don't have that scenario, okay? We know these are important values. We don't necessarily know what's going on. So we're going to do what is called the candidates test, which basically we're going to take each of our critical values and we're going to look and see what are the y values. Because the y value is your max or min value, right? The x value is your location. The y value is your max or min. So we're going to do again what we're calling the candidates test.
Noel Carpenter, please come to the high school office. Noel Carpenter.
And now, in my notes I have it set up horizontally, but man, we're more vertical people. We're going to go vertical. Okay. So, first of all, what is my interval here? Are these critical numbers in my interval?
Yeah.
Yes, they are. So now, remember, what else we have to talk about? We have to look at these critical numbers. What else do we have to consider? We have to consider our endpoints. Because could a min or a max happen at an endpoint?
Yes.
It could. If the whole rest of your graph is higher and you're on an interval. Now, if we're looking at the whole graph, there's no endpoints to consider. So I'm going to put in negative 1 as an endpoint, negative 1/2, 3/4, and my other endpoint of 2. Those are the possible places where there are mins, maxes, something going on. What we're looking for right now, if you recall, are the absolute. Okay, so we're going to look at the y values. This is where the calculator comes into play. Now, in all honesty, would you normally have a calculator on a non-calculator problem? No, you would have to plug them in by hand, and it just wouldn't necessarily be too difficult. Some of these are a little more difficult, but like I did negative 1 in my head. Did I get it right? I did. The decimals aren't as easy to do in your head, so. Now remember, either plug them in each individually, or type your equation into y1 and plug them in that way. Your call. What are you more comfortable with? Let me know when you get an answer.
How do we get the y?
Zero, negative 1.
fine. Are you talking about like that right there? Yeah. Like alpha F3 or F4 is where I do.
Plugging this into the original.
Yeah, okay, good question, good question. I didn't clarify that. We are plugging these into the original, not into your derivative. I don't know which way you guys were doing that, but I was like, why are you getting 0? Yeah. Candidate's test is going, and maybe instead of saying y up here, I should say f of x. Okay, it is going into the original because we want to know on the original graph what's mins and what's maxes. Is that better?
Yeah.
Sorry. Okay.
19, 4.
Yeah, I got that.
Yeah. I have written on my paper it as a decimal,
4.75.
4.75. Not that you can't go fraction, but when I'm comparing these, I want it easy. Anyone got the others?
Negative 49/16 or negative 3.062.
Negative 3.06 what?
2.
25. Okay. Because I had written on mine negative 3.063. So that's why, which I'm fine with 2.5. Then what do you get when you put 2 in?
36.
Okay. What do you know?
36 is our absolute max.
Okay. And?
Negative
3.0625 is our absolute.
Okay. So we have a min value of negative 3.063. We have a max value of 36. Now, depending on the scenario, would you maybe need to give the whole ordered pair in a scenario? You could, okay? This just says find the absolute extrema. When we talk about min and max values, that's what they are. Okay. Got the basics? Because that's the basic. Look at those places where it equals 0. Don't forget to check endpoints. And if you looked at this, if you graphed this now, it would probably make sense. Okay? If you were to actually graph this and look on the specific interval, if I look at 8x cubed minus 3x squared minus 9x plus 2.
Oh yeah,
My screen. Now,
It's from like,
there's your graph. Do I care about that whole graph?
no.
No, I only care from negative 1 to 2. And if you look from negative 1 to 2, well, my screen doesn't go high enough, does it? Because what was it? It was 36, I think. Oh, shoot. Gosh, dang it. I have no idea what I've done now. Try this again. Okay, negative 1 to 2. I'm going to make my height go up to like 40. There we go.
Whoa.
Okay, and so now on the specific interval, you can see that height, yes? And you can see right here at negative 1/2 and at positive 3/4, there is a min and a max. But when we're talking about the entire interval, that's a higher max up there. Okay? And the key is to be able to do it without looking at the graph. Okay, ready to try B? Let's try B. G of x equals x minus 2 sine x on the interval 0 to 2 pi. What would you say about continuity? Continuous?
Yes.
I mean, it's a combination of x, which is part of a polynomial, sine of x, which is an oscillating function, both continuous. We should be good here. So, what are we doing? Find your derivative. Derivative of x minus 2 sine x.
1 minus negative, no, 1 minus 2 cosine x.
In my brain, everyone thinks differently here. The derivative sine of something is cosine of something. So that -2 out front just stays the same. It's just like the constant of -2. Okay, we're going to set this equal to 0. I'm moving my 1 to the other side. Yes, I ended up with 2 negatives from the moment. It's all right. Keep going. I'm going to have cosine x equals 1/2.
Inverse. Cosine inverse of 1.
It is, I mean, but I don't want you using the calculator to find it.
Oh, that's fair.
You know, this is,
Cosine
when does cosine equal 1/2?
Oh.
Using what you know.
pi over 4.
Pi over 3.
It's not pi over 4, because pi over 4 is square root of 2 over 2.
Pi over
So it's either pi over 3 or pi over 6.
Triangle.
It's pi over 3, isn't it? Yeah, it is. I had to start, started second guessing myself. Now, guys, what's your way to find that?
Triangle.
Okay, then do your triangle, right? Now, you know, for me, it's always, my brain just goes for the chart here. And so it was me just trying to process through the chart. If you're a triangle person, do the triangle. Now, okay, so it is pi over 3 there. My notes agree. That way if I'm having an off moment. Is that my only critical value there?
I'm gonna guess that.
I put a comma, so there's your hint. Because what interval are we talking about?
Oh, you can also be all the other ones.
It'd be 4 pi over 3.
Yeah.
In my math.
See, 1, 2, 3.
What other quadrant do we need? We're looking for where what
Cosine
cosine is
1/2.
positive 1/2.
Positive one.
So cosine being positive, we're going down here.
8 pi.
And so
5.
5 over 3. Because it's 1 less than 2 pi.
So 5.
Yeah, because 6 pi over 2 pi.
you guys with me?
Yeah.
That's really sloppily written in there, but the other one we're looking for is 5 pi over 3. That's the basic trig you guys have got to be able to do. I think we're a little rusty, right? Okay, so now let's talk candidates test here. What values are we testing to find our min and max here?
Pi over 3. No, let's start with 0. Pi over 3. 5 pi over 3, 2 pi.
And we included 0 and 2 pi because we're on an interval.
Yes.
Okay? Okay, this is definitely a calculator type thing,
Yes.
because when you're doing x minus 2 times sine x, this is a calculator. I mean, other than the 0 is not bad. I got that one. All the others are going to be decimals. Although I can do the 2 pi in my head, I guess. We should all split up, everyone do a different one.
pi over 3.
Okay.
Negative 0.685.
Okay.
No.
What else do we have?
5 pi over 3 is 6.968.
Okay. I just have 3 decimal places, I guess, when I look at my notes. So, what about 2 pi?
6.28.
Yeah. Which my brain knows. I already knew it was 2 pi, but I just didn't know what the third decimal place is because in my brain 2 pi is 6.28. So. Okay. What do we know?
5 or 6.968 is our absolute max. And then the negative 0.685 is absolute min.
Okay. You guys with them? We have a min at the negative 0.685 or of, and we have a max of 6.968. Okay, and I could graph all of these on the calculator and show them to you, but I want to keep us moving.
Oh, this guy's a fun guy.
Okay, C,
Oh, wow.
sine squared x minus cosine x.
Nope.
It's sine and cosine. Those are two continuous functions, so we should still be continuous, which means we're going to find our derivative. Derivative of sine squared x.
2 sine. Goes 2 cosine x.
No. 2 cosine squared x.
Oh shit.
What's the question?
2 sine squared x times cosine.
Yeah.
I don't know. I think I said
Sine
it.
x times
Okay, so the derivative of something raised to the second
And then it's the derivative.
is 2 something to the first. So 2 sine x to the first
Times the derivative of the inside.
times the derivative of sine, which is
2
cosine.
sine x cosine.
so you end up with 2 sine x cosine x. Because you apply the power rule first, moving the 2 out front, and then that becomes a power of 1. And then the derivative of the inside, which is sine, derivative of sine is cosine. Minus derivative of cosine,
Negative sine x. Or just negative sine x.
It'll be negative sine x, which will lead to plus sine x, right?
and again, you do you. My brain says, what's the derivative of cosine? That is negative sine. And since it's already a negative, then that's going to flip it to positive. Okay. Set this equal to 0. And what do you see we can do here? Factor out a sine x. So sine x times 2 cosine x plus 1 equals 0.
So just
Set each factor equal to 0. So sine x equals 0. And 2 cosine x plus 1 equals 0. Okay, so now we want to talk about when does sine x equal 0 and when does cosine x equal negative 1/2.
cosine x equals negative 1/2 at 2 pi over 3 and 3 pi. 4 pi over 3.
Okay. I hadn't even done this recently enough to remember that this helps us with the next problem, but here was our positives, yes?
Yeah.
So here are the negatives. So 2 pi over 3 and 4 pi over 3. Okay, yeah. When does sine equal 0?
Pi and
It'd be just pi because it's only to
0.
3. Wait, I don't know.
Pi and 0 and 2 pi.
Okay? So sine starts at 0, and then it's every pi. So 0, pi, 2 pi, 3 pi, 4 pi. I only listed 0 and pi because my interval starts at 0. It includes pi, but then it stops before 2 pi. All these fun little catches, yes? Okay. Candidates test. Somewhere we've got a min and a max. Okay, we are testing 0, 2 pi over 3. Well, darn it, I was skipping to 4 pi over 3, but okay. Pi, no, you're right. 4 pi over 3 and 3 pi over 2. And it's not that they have to be in order. So, and then it's plugging them into the calculator, yes? What are we getting?
Pi is 1.
Pi is 1. I know 0. 0 is -1. I'd already done that one in my head.
Four pi over 3 is 1.25.
4 pi over 3 is 1.25.
You do sine
3
squared.
pi over 2 is, well, it's just sine of the number squared.
You can just do the calculator to do the sine squared. Is that what you're asking?
Yeah.
It's not a big deal on here because if I just need to do, say, sine of 0, well, let's do one that comes up something. So sine of 2 pi divided by 3, I believe you can just do the squared after it,
Yeah, you can.
and that will do it. If you needed to do the sine of 2 pi over 3 squared, you'd have to do an extra set of parentheses in here. And then square that, and then in those parentheses, like if you were trying to square, I'm just showing you the alternative. If you're trying to square 2 pi over 3 and not square sine,
Then you do it.
you'd have to put the square inside the parentheses, if that makes sense. Okay. Okay, what do we find? What's my min? What's my max?
You got a max of 1.25.
We got 2 of them, but yep. 2 places the same max happens.
It doesn't matter if it's the same.
Nope. It's still going to be the absolute max. It's still going to be this one place or the highest value.
Absolute negative 1.
Okay. Two more.
You can do
I
it.
gotta move. Yeesh. Okay. I would say we skip these, but no, we need to talk about them both. So, D, f of x equals natural log of x squared minus 9.
1 over x squared minus 9 times 2x.
I'm gonna pause you. What's the question we need to start with?
Is it continuous?
Is it continuous on this interval?
Natural log.
What do you know about the inside of a natural log? It has to be positive, yes? Okay, you can't take the natural log of a negative number.
I would just skip it.
Wait, -2 squared would be 4 minus, yeah, that's going to be negative.
Right? It works like it works at 5.
Yeah.
But it doesn't work on numbers less than 3. Okay? So, f of x is not continuous on that interval. And so since we don't know that, it's not continuous on the entire interval, EVT does not apply. Okay? So f of x is not continuous on -2 to 5. So EVT does not apply. Doesn't mean there's not a possible max and possible min there, right? I just can't use the basis of EVT to find them. So, okay. And E. Okay, this is a cube root. Square root graphs are a little bit more difficult. Cube root, remember, you can take the cube root of a positive and a negative. So cube root's doable. Okay, like, I don't know if you remember, the cubic equation is that, right? The cube root is the sideways version. I don't exactly know what that looks like. Actually, I do. When you square it, I believe it takes this piece and flips it up, so it becomes more like that type thing. Yeah. Okay, so we need to find the derivative, yes? What do you know about, what is this before we start?
X minus 2 squared to the 1/3.
Put it all together, though, instead of having a squared and a...
2/3, sorry.
You're right, you were getting there. So I'm going to rewrite this before we go, that this is x minus 2 to the 2/3. Agreed? Derivative, here we go. Do you agree with my derivative?
No. That. No.
No, it's subtract 1.
No, but like, do you not do the derivative of the inside too?
Oh, and what is the derivative of the inside? I mean, I could say times 1, but
Oh, you times it.
were you trying to add it?
Yeah.
Okay, no, that's a problem. Because I'm just timesing 1, that's why I just ignored it. Okay. Now, what is this written in a better form without the negative exponent? Negative exponents go where?
Don't know.
To the denominator, yes? So what I would do here is this x minus 2 to negative 1/3. I take it to the denominator. Yes, it's x minus 2 to the 1/3, or it's the cube root of x minus 2. The 2/3, I would put the 2 up top, the 3 out front. The 2/3 is a constant. It doesn't really matter. Now, when we start asking about when does this equal 0? When does a fraction equal 0?
When the denominator is...
Not when the denominator equals 0, but when the numerator equals 0. Can this fraction ever equal 0?
No.
No. So this fraction will never equal 0. But keep in mind, our critical value theorem, or whatever it's called, when the derivative equals 0, or when the derivative is
So the denominator.
undefined. So when the numerator equals 0 would make the derivative equal 0. That's not happening. But we also need to talk about when it doesn't exist. When is this derivative going to not exist? So we're looking at when the derivative equals 0, or when the derivative does not exist. When does my derivative not exist?
X equals 2.
X equals 2, right? In other words, right here does not exist. Set x minus 2 equal to 0. And so at x equals 2. That is a critical value. Okay, that is a critical value because it's where the denominator doesn't exist. So, for our candidates test, what are we testing?
1, 2, 10.
1, 2, 10. We're plugging those into h of x, and we get 1, 0, 4.
All right.
Says my answer key. Fair enough?
Yes.
Yeah.
Okay.
Min of 0, max of 4.
I can go with that. Min of 0, max of 4.
Nice.
And you could give the ordered pairs if you needed them, right? Okay, guys. You have homework related to this
Whoa.
to go and do. Okay?